So this problem is another type of H problem. This one's a little bit easier than the one I had you guys do for the warm-up. In general, when you have a problem where you have a variable approaching 0, but you also have another variable, so we've got like x's and h's in this problem. In general, your goal is to hopefully get this h in the bottom to cancel with a h in the top somewhere, and then you'll be able to plug in to do direct substitution. So for this here, if I were to plug in 0, I'm gonna write it down because that's we're supposed to do that every time. A lot of times I'm lazy and I forget. But we're supposed to do that every time, at least in our head, right? We got 2x plus 0 squared minus 2x squared over 0. Well, that is going to be 2x squared minus 2x squared over 0. And something minus itself is going to give us 0 over 0. So we are getting indeterminate form on this. So it's fine with me if you're just writing that, thinking of that in your head and not actually writing it down, but you always need to think of it, because if it's not 0 over 0, then you've got an answer, and you don't have to do anything else for that. And any work that you try to do is probably going to be wrong in that case. So here, though, we've definitely got to do some more work. Where I have this x plus h squared, I'm going to need to expand this out. It's really like your only option for this because we don't have a complex fraction here. We've got a fraction but not a complex fraction. So I'm going to expand this out just like I was showing you up here. It is a square double square. In fact, this one's the same square double square that we had in the warm-up. So it will look like this. We'll have 2 times x squared plus 2xh plus h squared minus 2x squared, and this is all over h. And we would need to distribute that 2. So we got the limit as h approaches 0 of 2x squared plus 4xh plus 2h squared minus 2x squared all over h. And what can happen now? Right? My 2x squared and my minus 2x squared are going to cancel each other out because one's positive, one's negative. That is going to leave me with the limit as h approaches 0. Now, what do you notice about what's left in the top? What do both of these terms have? An h. For these types of problems, that should happen pretty much every time. So what could I do with that h? Factor that on out. I'm going to do that in this step as well so I can save myself a step. You can, and you can do it either way. You can factor out the 2 if you want, or not. The h canceling is going to be what's really important for getting the right answer. So you can take out the 2 if you want, or not take out the 2. You'll get the same answer in the end for that. So it is really just up to you on that. There. And so the h will cancel, meaning that we now just have the limit as h approaches 0 of 4x plus 2h. And if you had factored out the 2, you'll have 2 times 2x plus h. You're going to get the same answer when you plug in here anyway. Once that h cancels, you want to plug in 0. What do we plug in 0 in for? The h and the h only, right? So this is going to be 4x plus 2 times 0, which is just going to give us 4x. I could have let off with that one, but it was more fun to make y'all try on the other one first. More of the H problems are going to look like this than the other type. Okay. Also, our textbook doesn't use H's. Our textbook's not that old. It's starting to get old. I think it's like copyrighted in 2017 or 18 or something. In the world of textbooks, that's not too old. But it is like, it's been around a lot longer than that. They just keep making new editions of it, you know. So it's a little bit older. If this problem were in our textbook, it would look like this. It would be the limit as delta x approaches 0 of 2x plus delta x squared minus 2x squared all over delta x. So when we go to do some problems with this from the textbook, this problem is going to have a delta x instead of an h. My suggestion to you, because pretty much everything AP puts out, they use a h these days. My suggestion to you on that is just to change your delta x to a different variable. The letter that they most typically use is a h. So if you just change all the delta x's to h's there, then you just work it out like we've got here. Delta x is a single variable. It's not like a number times x. It's the change in x is what it means right there. And they're using that as just another variable. So I think it's easier to deal with if you change it to an h, though. So we will see that in our textbook. Also, we're going to see this come up again. I knew the answer to this question was 4x immediately, and not because I have it memorized, but because I know what this means. And I know how to do it without having to do the whole thing. And eventually, I will teach you, but I can't teach you yet. So just know this like H stuff is going to show back up. It shows back up in Unit 2. Yeah, so it's going to show back up in Unit 2. So right now you're just like working through the mechanics of it. It's going to show back up in Unit 2. All right, now the next two are not written on your paper, I don't think. Or did I reprint? I didn't reprint these, did I? Okay. Was there a... No, there's nothing else. There's probably room for you to squeeze these in there. Or if you want to get a different piece of paper, we're going to try a couple with some e's in them. This stuff is so good. It's making you remember all kinds of stuff. Some of calculus is such good algebra practice because you got to know the mechanics of it. All right. So, for this problem, if I try direct substitution, let's try that first because you always want to try direct substitution first. I would get e to the 0 minus 1 over 1 minus e to the negative 0, but negative 0 is just 0, right? What is e to the 0? It is 1. Anything to the 0 power is 1. So I'm getting 1 minus 1 over 1 minus 1, 0 over 0. And 0 over 0 is the indeterminate form. It tells us to keep going. All right? So, for this, the trick in doing this problem is the fact that you have a negative exponent here. All right, we got e to the negative x. Does anybody remember what we can do with a negative exponent so it won't be negative anymore? Yep, send it 1 over e to the x. So I'm going to rewrite this because those negative exponents are like bad children. And bad children, you lock them in the basement, right? So, but you only do it for like that one term right there. So this stays the same, and you got 1 over e to the x. So we thought this was some sort of e problem. What has it really turned into now? Fractions inside of fractions. This is what we were doing yesterday. This is a complex fraction problem, okay? So with complex fractions, we want to get common denominators, flip, and multiply if we can. In this case, it's the denominator here. Like this is 1 over 1. What do we need to multiply that 1 over 1 by so we can get common denominators here? E to the x. So we're going to multiply by e to the x in top and bottom here. And that is going to give us the limit as x approaches 0 of e to the x minus 1 over, here we're going to get e to the x minus 1 all over e to the x. And I'm going to put some parentheses around that to kind of make sure I'm doing these things right. And then dividing fractions is easy as pie. You can flip the second and multiply. So we're going to have the limit as x approaches 0 of, this is just e to the x minus 1. If you want, you can put that over 1. That might kind of help you keep things straight there. And then you're multiplying this by e to the x over e to the x minus 1. What can happen now? Okay, e to the x minus 1 cancels with e to the x minus 1 because the stuff is multiplied together, right? So it's okay to do that. So now we're just getting the limit as x approaches 0 of e to the x is really all we got left, which is going to be e to the 0. And what is e to the 0? 1. So 1 is our answer there. Okay, so if you see some negative exponents, there's a good chance you need to change that to a fraction and do a complex fraction with it, like we were doing yesterday. Okay, questions there? All right, I got one more for you. So, if I direct substitution this one, I would have 2e to the 0 plus 3e to the 0 minus 5 over e to the 0 minus 1. And e to the 0 is just 1. So I've got 2 times 1, which is 2. 3 times 1, which is 3, minus 5. And 1 minus 1. And that, in fact, is going to give me 0 over 0. Mm-hmm. Lots of times. It doesn't have to be, but lots of times. Yeah. There's some that won't, but a lot of them are 0 for these. Yes? Oh, I think I have a, hold on. We could. Have I got a typo on this problem, though? I retyped these answers. I think I have a typo on this problem. I think you're not supposed to be able to. Let me open my old notes for this. I think you're supposed to be a 2x right there. because I'm pretty sure I was wanting you to have to use a different strategy here. Let's see. It would be here, here. I think I have a typo on these notes. I'm trying to switch them over to Google Slides because a lot of these are handwritten and they're ugly. And I bet I messed it up. Let's see. Oh yeah, there's supposed to be a 2 there. That's my mistake. Okay. I'm glad that you said that. There should have been, this is a typo, and I need to go back and fix it on these notes when we're done. There should have been a 2x right there. And if there's a 2x, it doesn't change this because there would be a 2 right there. It's still e to the 0. If there's a 2x, can I combine them? No. But you are correct. You would be able to combine them if there was not the 2x there. All right, so since we can't combine them, any ideas? I can factor. What's it going to look like if I factor it? Yeah, so it's like having a 2, this is like having 2x squared plus 3x minus 5, but instead of having an x squared, you've got like an e to the x squared, because I could write this, like when you have 2e to the 2x plus 3e to the x minus 5, you could write it like this, 2e to the x squared plus 3e to the x minus 5. So you're factoring like it is, let me use a u here, 2u squared plus 3u minus 5. But instead of actually being a u, it's e to the x, right? So when I break this up to factor it, I'm going to have 2 e to the x, and I'm going to have an e to the x over here. If I multiply those together, if I multiply 2e to the x and e to the x together, I get 2e to the x squared, which is 2e to the 2x. This is the number, like we're factoring, we got a 2 in front. I need to multiply to get negative 5, but I need to get a 3 in the middle, but it's not really add and subtract to get 3 because I got this 2. I kind of got to guess and check right here. What could I use? Almost. Because if I've got a minus 5 right here, I'm going to get a negative 3x. So I want a plus 5 and a minus 1 right here. Because when I'm checking that, I'll get e to the positive 5. I'll get positive 5e to the x here, and I'll get negative 2e to the x, which will give me that positive 3 there. Also, the whole point of this most of the time is to get something to cancel. Since the bottom is e to the x minus 1, there's a really good chance you're going to get e to the x minus 1 somewhere, so it'll cancel. Okay, so these do in fact cancel. And then we just have the limit as x approaches 0 of 2e to the x plus 5. We can do direct substitution here. 2e to the 0 plus 5 is going to be 2 plus 5, which will give us 7 for the answer. Okay. So we got about 30 minutes left. Let's take about 15, and we are going to work on this assignment. This is going to be your assignment for tonight. I'm going to give you about 15 minutes now because I think it's good to practice it